Today we're going to look at camera tracking in Blender. The reason we want to do this is so that we can insert CG objects into real-world footage. There's a few things we need to know about our footage before we begin. We need to know the model of our camera and the focal length of the lens being used. The example footage we are going to use was shot with a Canon T3i using an 18 to 55 millimeter zoom lens, zoomed all the way out to 18 millimeters. Blender relies on constant focal length for tracking, so using a lens with a fixed focal length would be ideal. If using a zoom lens, make sure you don't adjust the zoom during shots. If using a zoom lens not zoomed to one of its limits, you can find your focal length by taking a still image at the same zoom setting and checking the metadata of the image. As long as the camera and lens were meant to work together, the camera will have recorded the focal length when the picture was taken. The other thing we need to consider is that we need at least 8 points in our shot with high contrast to use as tracking points. In our example, we're going to use crosses that I put on the wall, but ideally you should find things that are already in the scene or look like they belong. And because we want high contrast, the better focused your shots are, the better tracking will be. Let's look at the footage we're going to use in our example. So that was the clip we're going to use. This image was taken without adjusting the zoom from where I shot the test video. And if we look under the properties and under the details, we can find that our focal length was 18 millimeters, and it will also tell us the camera model that we used. This other image was taken at a random focal length, and so if we needed to find it, we could do the same thing under properties and details. We can see that that picture was taken at a focal length of 29 millimeters. In Blender, the first thing to do is let's switch our view over the motion tracking view, and we come up with this. And then the next thing to do is import our test video. And we can just drop that right in. So this bottom part is the only one that we're going to be concerned with for a while, so I'm just going to tidy things up so that we have a little cleaner working space. Oops. Now that we've got our video imported, let's click this prefetch button. What that does is moves all of the video frames into memory so that Blender can work with it quicker. Let's also click the Set Scene Frames button. That will set the number of frames that the scene is going to render to the same as our video footage. Now let's look at adding our tracking points. We're going to use all these crosses that I've put on the wall. We'll have to do it for all of them, but we'll just go through a few of them in the video here. Before adding our tracking points, let's change our motion model to Affine. That's what works best for a flat surface. Now to add our point, we hold Control and click where we want to set it. We can zoom in on it and scale it. Until it nicely covers our mark. So I'm just going to copy a few of them. I can copy a whole group of them. And then I'll start placing them on the marks. Moving and scaling these are the same as any other object in Blender. And I'm going to bring this out. And if you haven't already noticed, in this pane here, this is what the track is looking at. So this window is how this box sees our mark. Now that we've put out all our tracking points, we can see how Blender actually tracks them. We can do them one at a time in groups or all of them at a time. So I'm going to select them all and we'll just give it a chance to try them all. It's not likely that it will track all points successfully the first try, especially these ones on the left hand side that are not in focus very good. Once we've selected everything, click the track selected markers. Now we can see what it's doing. Okay. So that did a pretty good job. You see this one that shows up in pink over here and has nothing on our cross. That failed to track. So we can use our arrow keys to move back and forth frame by frame and go in and see what went wrong. Okay. Okay, so let's scroll through. Back to the beginning. We can see it keeps on there. And again, we can see what it's seeing over here when that one's selected. And it just turns into a blurry dot. Oh, it goes back to a cross for a second. It's off center a little bit. We can grab that and move it. And then the next frame, it gets really blurry. So we can manually move it up to where it needs to go. So this was looks like it was kind of a bump in the camera motion. And it moved too much that this tracking box couldn't find the point again. So let's just do a couple frames manually. And so we just move frame by frame, grab it and recenter it. And it looks like it's gotten sharp enough it should be able to track it through. So let's just reposition, and we can reshape the box if we need to. Okay, that looks pretty good, and it should be able to track that through. Let's see, and it looks like it was successful all the way to the end. At the right end, there's a couple markers that went off screen, so let's deal with those ones. Let's do that one at a time. Select that one, and just scroll back. Oh, it only was the very last frame that it failed on. So just scroll back. And because the marks partially went off screen, it's kind of off center. So let's go back one more, and let's consider this the last good frame for that track. So we have a clear button that'll clear any of the tracking points after that frame. So if we click clear track after, it'll get rid of anything after that. And we can lock that tracking point using Control L. Let's go down here and check this other one that went off. It's pretty blurry for the last few. So if we went back and considered maybe this frame as our last successful one, we'll clear it after that and lock that one. And since everything else seemed to track pretty good, we'll select them all, press Control L and lock them. We can go back and unlock them if we need to change them later. So now that we've tracked all of our points, we can solve for our camera. And what that means, it's going to figure out by all our points moving how the camera actually moved in the real world. So to do that, we need to set up our camera and our lens. So under the camera portion, there's camera presets, and Canon APS-C is what all of the Rebel cameras conform to, and they have a sensor width of 22.3 millimeters. So if your camera is not under the presets, as long as you know the width of your sensor, you can still use that. Now under the lens, our focal length was 18 millimeters. So we'll set that. Then over on the left hand side, let's click the Solve tab. And just click Solve Camera Motion and see how well it does. Oh boy, down at the bottom here, we're told we have a solve error of 80, which is terrible. I've checked our camera information, and all seems well there. Okay, so let's have a look at the graph that we hid a little bit earlier. So let's get a new pane. And this is the graph we were looking at. So within this graph, the red and green represent the X and Y movement of our track points, and the blue represents our error, which we can see just explodes. I've gone back to the beginning. I'm going to try retracking everything. But for each track, we can change what colors it's looking at, or turn it into a black and white. So if we turn it black and white, that's what it would be looking at. Maybe if we turn on red and blue, seems to give us the best result. Okay, I've gone through. Turn on red and blue for all of them. Let's select everything. Clear everything forward and start again. We have to unlock everything. Clear forward, track selected. Okay, let's deal with the ones that we lost. Forward until now it's going wonky. So let's manually move it into place. Let's do that for a few. Just keep doing it. Okay, let's see if we can track it from there on. Okay, looks like we got that one now. Let's try solving again. Much better. So now we've got a solve error of 1.0423, which is almost acceptable. Anything under 1 is acceptable, but we can get that a little bit better by letting the camera solver refine a few things for us. So K1 and K2 are factors to do with the lens. If we let the solver tweak those, then we get a good result of 0.28. If we look at our graph again, we see our blue line at a much more acceptable level. If we had spikes in our error, we could go to those points and look for anomalies. The red and green represent the motion of our tracking points. If we've seen areas where not all the lines kind of followed the same pattern, then we could take those as one node moving. We could take that as one or more track points that aren't moving in the same general way as the other ones. Now they would all only ever be exactly the same if we were perfectly perpendicular to with what we were shooting and never turned or panned or tilted the camera. And if you right click on any one of these, it will select the track point that that line represents. So let's look towards the front where we know things got a little blurry. And let's say we consider this point to be an anomaly. Select that point and we can go to there. And if we look over here, we could use just a tiny tweaking. Whoops. Oh, but we've locked it. So we'd have to unlock it. We would think that moving it back to the center would make it conform more, but that spikes it out there even more. So let's just scroll through. And adjust Looks a little more. Yeah, okay. So we can see we had some issues throughout that range, so. It looks good. This one kind of had the same thing happen to it, so let's check that one out too. We can see that's where we have a rather high spike in error too, so let's tweak any that have a spike in motion. Okay, this one we should have expected. That's the one that lost its tracking right away. Let's see if tweaking those helped us out or made it worse. Now, I forgot to write down what we had got to. Looks about the same, wasn't it? Yeah. Our error's still kind of spiky there, so. We could spend some more time trying to tweak things, but let's go with this and call it good. We're below 0.3, so we'll call that acceptable. Now what we want to do is apply what it solved to the camera in our scene. So we can do that by clicking the Set Up Tracking Scene, and then we also want to click Set as Background. So let's change our view back to the default view. Now if we look at our camera here, we see that we've got all of these points here, and these points line up with the tracking points we used back in our motion tracking. And if we scroll through our frames, we can see that our camera moves. That looks about right. What we expected. As it was a pan from left, sorry, it was a pan from the right to the left. So the motion looks proper, but it's not pointing where we want it to point. We want it to point at this plane down here. Now this plane was added by clicking that Setup Tracking Scene button, and it's put here to catch the shadows from any objects that we have in our scene. Let's go back to motion tracking. And what we need to do is pick 3 points and we're going to use those 3 points as our floor. So I've picked those 3 points. If I go click floor, go back to our default view, now we can see the camera is pointing at the floor. Okay, but let's look from our top view. It's pointing at the floor, but it's not pointing, it's not oriented properly in our XY plane. It's almost upside down. And we also want to set the scaling. So let's say we wanted this cube in our scene to be a specific size relative to our camera. We know that this is a unit of, this is 2 units wide. So if we go back to our motion tracking and say we want that cube to be the same width as these 2 points would be from each other, we can click under the Set Scale button, click in there and set 2. Now click Set Scale and Apply Scale. If we go back to our default view, we can see that the scale of the camera relative to the cube has changed. But that didn't do anything for fixing our orientation, so let's go back to motion tracking again. And let's say we want this point to be our center. We'll select that point and click Set Origin. Go back to default view. So we can see it centered it on the cube, but again, it did nothing for our positioning, our orientation. So back again to motion tracking. And it would be convenient if we had a point directly up from our origin, but we don't. This is the closest one, so if we select that one, click the Set Y-axis, and go back to the default, then we can see that it set the Y. It set the Y orientation of the camera from those 2 points. So the point that we picked as origin and the point we clicked as set as Y. We can correct that. We can tweak our orientation by rotating it. We'll rotate around the 3D cursor. We'll rotate around the Z until it looks appropriate. And we want to orient by our tracking marks, not by our camera, because we know that our camera's not level throughout. So that looks pretty good. We can scroll through. That looks good. If we press 0 on the keypad, it brings us to the camera view. And we can scroll through and see if the camera sees what we want. Let's set our render type to cycles render so we get a little bit nicer result. And at any point, if you hit F12, that's what that frame would look like. That would have went a little bit faster if I would have set that to GPU. Just going to scale the cube down now, bring it up above the surface. That's what it would look like now. So let's give our cube a texture. Just pick a random blue color. Let's give it some roughness. One more test render before we render everything. Okay, that looks pretty good. So now when we're ready to render out our entire range, we can turn this resolution back up to 100%. And one other thing we need to set our frame rate. So let's get our frame rate from our original video. We can get that from our properties under details. We have a frame rate of 29.97. So let's set our frame rate to 29.97. Let's set our output location. Leaving it as your default C temp is fine if you choose. Choose our output type. We'll just do the easiest one of an AVI JPEG. We'll save. And then if we click the animation button, it'll take off animating. Let's wait and see how long each frame is going to take, and then we can have an estimate of how long we need to wait. Note that the test render on the single frames we did before was only at a resolution of 50%. So these being at a resolution of 100% is going to have 4 times the pixels, because both the height and the width doubled, and therefore the overall number of pixels quadruples. So it should take approximately 4 times as long as a single frame. And our single frame took 32 seconds before, so this should take somewhere in the range of 2 minutes. Okay, so that took 2 minutes and 14 seconds for the first frame, or 134 seconds. So if all of them take approximately the same time, 134 seconds times 232 frames gives us 31,000 seconds, which is 518 minutes, or 8.6 hours. I'm back with the result, which can be found under the folder that we specified under the output, which is here. The naming of video files when rendered by Blender is the number of the first frame, dash, and then the number of the second frame. So here we rendered a file from frame 1 to 232, and here's the final result. Here's the result of another one with some more items in the scene.